I'm Liam Taylor. I work here at Uswitch as a senior data analyst. I'm going to be talking about how in our team we communicate during testing. This is particularly for A/B testing. So when you think about an A/B test, you generally, well, I would like to think we went along a process like this. We gather some amount of data, wherever that may be. We do some test. We then test if it's significant, and then we make a decision whether it's yes to change to the winning variant or no, and we make it either change it anyway or we stick with the control. But throughout my time here at Uswitch, I've been asked loads of questions, and at the time I could only think of 3, but they generally get the same basis, which is, how is the variant performing? This could be right in the middle of the experiment. Is the test significant yet? And can we stop the test now? So what that equates to is essentially we gather some amount of data, we do a test, we then make a decision, yes or no, but if it's no, we loop back in and we keep on going round and gathering more data until we get to the point. The problem with this is that if we do this, so as an example, if we were testing something for 20 days, or we had a significant level of 5% and we did a test every day, there would be a 64% chance that we'd find one significant result. The expected value, we would expect one significant result, false positive in this time. So, how can we communicate during a test? So we can do 2 things. We can either plan to peak and reduce our significance level during the test, or we can do sequential analysis. So I'm going to talk something that I championed here at Uswitch and something I really like, which is sequential analysis. So what is it? Well, it's a random walk. So it's essentially flipping a coin or walking up and down. It compares the number of sales. Now, I said sales here, but this is just the event you're measuring at the end in your result. It also very clearly indicates the performance of your result to a wide range of skills. This is from analysts. I've had, there's a marketeer here at Uswitch who, this is his favorite chart when an A/B test is going on. And the best thing is it can actually tell you if a test should finish early. So what does it look like? It's very exciting when nothing happens. So this is an example of a test that has no significant difference. So the key features there is a sales difference that we look at, and we have 2 bounds, an upper and a lower, to which we can make a decision from. So as you can see, there's not much variance in our sales here. So in the 2 groups, they probably should be from the same distribution. It's very easy to see and clear to give to anyone of any sort of, whether technical or non-technical, the message that this test is showing that there's not much difference. And then when you get to the end, you just proceed as normal and make decisions. You do your normal statistical tests, look at variance in different groups and segments. So that's sort of the boring one. The one that I always get excited about is when something happens. So this is when the test variant that's going up, it actually performs better. And as you can see, there's no pointer, but the little red circle there shows that it's now outside our bounds, the upper bound, so the test variant is performing better. So it allows us to quickly see, and everyone to see, that it's performed better. It also means that in this case, we'd be able to stop the test about 2/3 into the number of sales we'd expected. So we can quickly make changes, and if you make changes quicker, the little marginal gains, you'll make a lot of difference there. But there is a few limitations on this. So there has to be an even split between 2 variants, otherwise you would expect your sales to go one way. You can get around this by sampling both, so they're even variables, even amounts. It does require 1 success per user, so because we use sales, we just use if a user buys, then it just counts as 1. And on the graph, it only compares 2 variants. You can then just repeat it for the combination. So why do I like this? Well, this is a statistically sound method of comparing. It uses confidence intervals to build that. It's also very easy to understand. I can walk into a room in my team with anyone in there and easily explain and hopefully get the message across that one is performing better than the other or there's no difference. And it also allows for quicker decisions. That is actually my talk. It's a quick one. So any questions?